First, I'd just like to give you a short postscript to yesterday's talk on policy, which was, yesterday there was an article in the Telegraph, which was an interview with President Santos of Colombia, in which he was very, very strongly calling for the end of the world on war on drugs. So it really is moving forward in both policy and science at the moment. And I do think that after decades in the wilderness, psychedelic science is really coming to have a renaissance. And I think we can see that from both our research and many other research programs around the world. It's really beginning to bear valuable fruit, not only in our understanding of brain function and consciousness, but most important, also in terms of new clinical applications. In this talk, I'll briefly touch upon, first, why neuroscientific research is so important and why I set up the Beckley Foundation. Second, how our pilot studies cast new light on the mechanisms underlying the changes in consciousness brought about by psychedelics and suggest new avenues of treatment for major scourges like depression and addiction. And third, give a scientific explanation of why psilocybin and MDMA can be such valuable aids for psychotherapy. If it is well directed, a neuroscientific pilot study can provide invaluable information about changes in cerebral circulation and brain function, as well as showing how a psychoactive compound affects consciousness and how it may be harnessed to overcome trauma and to enhance health, well-being and creativity, among many other qualities. Brain imaging studies are an ideal complement to clinical trials. They provide new discoveries to drive medical advances, as well as new explanations that give medical research a powerful neuroscientific underpinning. In 1966, I became passionately interested in the physiology underlying the mechanisms of consciousness and the ego. I'd met a Dutch scientist of exceptional insight, Bart Huges, who had developed two new hypotheses, one concerning the irrigation of the brain and the changes in blood supply to the brain underlying altered states of consciousness, and the second describing the physiological basis of the ego as a conditioned reflex mechanism based on word recognition which directs blood to those centres most essential for survival while repressing blood flow to other brain centres. This was the first time that a mechanistic explanation of the ego had been given. It also provided the first mechanistic explanation of how brain functioning can be altered by such practices as meditation, yogic breathing, and ingestion of psychoactive substances, to name but a few. The underlying theory was that these practices brought about a change in blood supply to the brain, together with a loosening of the repressive control of the ego mechanisms over consciousness. This new explanation of the ego as a system superimposed over the rest of the brain could not, in those days, around the 60s, be tested. However, with the development of more advanced brain imaging technologies, and particularly fMRI in the early 1990s, it became possible to observe the changes in blood supply and brain function correlated with subjective experience during altered states of consciousness. In 1998, I set up the Beckley Foundation with two main aims. Firstly, to investigate consciousness in its changing states using these new technologies, and secondly, to reform global drug policy. I invited some of the world's leading scientists, including Albert Hoffman, Sasha Shulgin, Colin Blakemore, Dave Nutt, Liz Iverson, and Dave Nichols, among others, to form a scientific advisory board for the Beckley Foundation. In 2007, after several years of persuasion, Dave Nutt and I embarked on a collaborative program of research. I was keen to start with psychedelics, but Dave advised caution, so we started cannabis. In 2009, when Dave moved from Bristol to Imperial College London, we set up the Beckley Imperial Psychopharmacological Research Program and started a series of pilot studies using psilocybin. The research was conducted by Robin K. Harris, whom I had directed to Dave in order to do his PhD. So much for the background. The program has proved to be a dream come true. With very little funding, we have targeted our research to look at changes in blood supply and brain function, underlying the changes in consciousness brought about by psychedelics. The findings have been both surprising and exciting. Last year, we started publishing our results from a series of studies using fMRI and MEG, imaging the brains of volunteers who had received an intravenous infusion of psilocybin or placebo. The findings were confirmed with two different fMRI imaging techniques, ASL and BOLD, which both give information about the changes in blood flow that result from the brain's metabolic activity. The results were further confirmed and expanded using MEG images, which maps changes in activity by recording magnetic field changes produced by electrical currents, i.e. neural activity. Contrary to our expectations, particularly mine, we found that, compared with placebo, psilocybin decreases blood flow and activity, particularly to the network of highly interconnected brain regions known as the default mode network, or DMN. All the data showed reductions in blood flow and the neural activity to this important network, and the degree of the reduction correlated with the subjective effects of psychedelic experience. That is, more intense experiences correlated with larger decreases in blood flow to the default mode network. We also found that the centers of the network became less connected with each other and with other brain regions. The default mode network closely corresponds with Bart Huges's concept of the ego as a top-down controlling mechanism. The brain is not a free-for-all among independent systems, but a federation of interdependent components that is hierarchically organized. The DMN sits at the top of this hierarchy, exerting a top-down control on other brain regions, which feed their information into it to be either repressed or routed onwards. The censoring activity of this superimposed mechanism reflects Aldous Huxley's metaphor of the brain as a reducing valve, as well as Bart's description of the ego as a conditioned reflex mechanism, which censors what is allowed to enter consciousness by controlling the distribution of blood in the brain. As in Bart's model of the ego, the development of the default mode network begins after infancy, during the time when language and self-control are being acquired through conditioning. The default mode network accounts for much of the brain's intrinsic activity and is particularly active in the resting state, i.e. when we finish a task and are engaged in inwardly directed thinking, such as introspection, daydreaming, and the recollection of autobiographical memories. Conversely, when we engage in externally focused tasks, the activity of the default mode network decreases, while activity of the so-called task-positive networks increases. In normal consciousness, the default mode and the task-positive networks are strongly anti-correlated, i.e., as one becomes more active, the other becomes less active. Taken together, these networks form the neurobiological basis of the ego-superego, as described by Freud and later elaborated by Barth. To summarize, the default mode network comprises high-level cortical nodes that are highly connected to each other and to subcortical systems. These centers include the medial prefrontal cortex and the posterior cingulate cortex, as well as parts of the thalamus and other areas. Psilocybin acts by constricting the blood flow to the default mode network and thereby decreasing its control and repressive activity. Thus, sensory and emotional impulses, which would normally be repressed, reach consciousness and users experience a spontaneous, unconstrained mode of thinking, a more fluid and plastic state of consciousness. This state more readily allows access to areas of the brain normally kept repressed, i.e., traumatic memories or indeed spiritual awareness. Also, under psilocybin, the anti-correlation between the internally focused default mode network and the externally focused task-positive networks becomes weaker, and the two networks become coupled, tending to act in synchrony. This also happens in meditation and psychosis. As a result of this coupling, there is a loosening of ego boundaries as the distinction between inner and outer worlds becomes blurred. Most importantly, the subjective intensity of the psychedelic experience correlates with the extent to which the activity of the default mode network is reduced. It is worth noting that the centers of the default mode network, whose blood flow and activity are particularly reduced by psilocybin, include the medial prefrontal cortex and the posterior cingulate cortex. Interestingly, it has been observed that in people suffering from depression, the medial prefrontal cortex exhibits both chronically raised activity and increased connectivity with the posterior cingulate cortex. This hyperactivity will result in thinking becoming rigid and inflexible, leading to an endless cycle of self-obsessed negative rumination. Our findings that psilocybin decreases both the activity of the medial prefrontal cortex and its connectivity with the posterior cingulate cortex suggests that the drug may provide a valuable new avenue of treatment for depression, hopefully allowing the rigidly negative patterns of thought to be reset. Recognising the value of this research, the UK's Medical Research Council has awarded over £500,000 for a clinical trial to further investigate the results, the use of psilocybin as a treatment for depression. Our brain-imaging study into the effects of psilocybin is the first time that anyone has shown that the most basic effect of psychedelics is to reduce blood flow to the default mode network, thereby loosening the grip of the control mechanism and permitting a looser style of awareness to surface into consciousness. This would explain why the psychedelics are conducive not only to accessing repressed memories and alleviating depression, but also to experiencing mystical states, to enhance creativity, and to seeing the unity and interconnectivity of all things, and our place in the greater whole. All of these characteristics can enhance the nobler aspects of the human personality. Thus, our research studies with both psilocybin and MDMA have gone a long way to giving a neuroscientific explanation as to why these compounds can be such valuable aids in psychotherapy. Whether it is overcoming post-traumatic stress disorder, addiction, or anxiety associated with terminal illness. By facilitating the access to repressed memories, even those which have for much of a lifetime been closed off from conscious thought, the psychedelics facilitate the washing out of toxic memories, which can help free the person from their unconscious grip. Most of our studies image the brain in participants in the resting state. However, in some of the studies, with both psilocybin and MDMA, we asked participants to form a series of memory tasks so that we were able to correlate the brain imaging findings with their subjective reports and to compare both psilocybin and MDMA with placebo. With psilocybin, the subjects recalled a series of prearranged positive autobiographical memories. With MDMA, they were asked to recall both favourite and worst memories. When we introduced the memory recall task with psilocybin, we found an increase in blood flow and brain activity in visual and other sensory regions of the cortex. During the period of recollection, as opposed to a deactivation of these regions under placebo. Correlating with the brain imaging findings, subjects reported their memories as significantly more vivid, real and visual under psilocybin than under placebo. Furthermore, the vividness of the memories showed a positive correlation to the subjective well-being reported later by participants. In the memory recall study with MDMA, subjects rated their favourite memories as more vivid, emotional and positive than with placebo. Correspondingly, several brain regions were more strongly activated after MDMA than after placebo. In contrast to favourite memories, which showed increased emotional intensity after MDMA, worst memories were rated as less negative after MDMA than after placebo. Corresponding with the subjective findings, brain imaging showed that areas involved in emotional response to negative memories were less activated after MDMA than placebo. This provides a neuroscientific explanation for the clinical observations that MDMA is helpful in the treatment of post-traumatic stress disorder. By decreasing the brain's emotional response to painful memories, MDMA allows these memories to be recollected without the patient becoming overwhelmed, so that the traumatic memory can be worked through in the therapeutic setting. I'm delighted to say that recently our protocol for LSD study has gained ethical approvals. The study will investigate the physiological neural mechanisms underlying the subjective effects of LSD and its effects on perceptual and cognitive functioning. This exciting research will be the first ever to use modern brain imaging technology during an LSD experience. I've been trying to do this research for now 30 or 40 years, so I'm really I'm hopeful that it will provide even more significant advances in the psilocybin and MDMA research, both in our understanding of brain function and consciousness, and in the development of potential new clinical applications, and maybe even the removal of the taboo which has completely restricted research into LSD. In this study, I'm keen to introduce more task-related activities in order to stimulate the brain and thereby see if it is more active. More active under LSD than under placebo, which is what I would expect. We plan to make a short video with inspiring music and wonderful images to show to the participant, which may trigger a mystical experience, which can then be mapped using fMRI and MEG. I once mapped using MEG a very high-level meditator who had a mystical experience in the MEG machine, and it was very interesting to map that experience. I'm particularly excited about this study, and as I had promised Albert Hofmann that as a 100th birthday present, I would open the doors to scientific research into his beloved elixir. In order to test the hypothesis that psychedelics potentiate problem solving and creativity, we need to develop new creativity tests, as the ones currently on offer do not catch the kinds of creativity engendered by psychedelics and cannabis. I would now like to say a few words about another of the Beckley collaborative scientific projects. In 2008, in collaboration with Roland Griffiths, this wonderful group at Johns Hopkins, we conducted the first study in modern times to harness the power of a psychedelic in treating addiction, in this case for nicotine. The protocol will be an intensive course of psychotherapy, including 3 sessions with psilocybin. Initial results have been absolutely remarkable, with almost every participant who has received psilocybin managing to quit smoking and to remain verifiably abstinent on follow-up. There's been no return to regular smoking. This success rate is far in advance of what we see with any other method of treating addiction. I believe our Beckley Imperial studies demonstrate how well brain imaging studies complement clinical studies. They show how psilocybin loosens the control of the repressing and organizing system of the brain and temporarily grants the brain a greater degree of fluidity and plasticity, in which old restrictions are broken and there's greater capacity to form new connections. Importantly, once formed, these new connections are enduring. So a change brought about by a relatively brief psilocybin experience can become consolidated and lasting. Many other people who have told me that a psychedelic experience from long ago changed their life for the better. I'm very excited about the work that the Beckley Foundation Scientific Program can do over the next few years. I feel that we're at the beginning of a new era when we can really open up all sorts of areas as it gets easier to get permissions to do these studies, and as we develop more connections with scientists willing and able to embark on them. And it's really a very exciting time to compare how the different categories of scientific substances act in the brain and how they can be used. We're just about to begin work on an ayahuasca study, and there's all sorts of exciting things in the past. So, the beginning of the time.